डियर स्टूडेंट्स, आज हम चैप्टर 10 का लेक्चर 2 करेंगे, जिसमें हम ये डिस्कस करेंगे कि व्हाट इज एंगुलर मैग्निफिकेशन एंड व्हाट इज द रिजॉल्विंग पावर ऑफ एन ऑप्टिकल इंस्ट्रूमेंट. First of all, we are going to discuss angular magnification. Angular magnification is defined as the ratio of angle subtended by the image at the lens to the angle subtended by the object at the eye when the object is placed at a distance of least distance of distinct vision. Also remember that for defining angular magnification, the object should also be formed at a distance of least distance of distinct vision, at a distance of 25 centimeters from the lens. The ratio between beta and alpha, the ratio of angle subtended by the image at the lens, so when the image is formed at a distance of 25 centimeters to the angle subtended by the object at the eye, when the object is placed at a distance of least distance of distinct vision, that is 25 centimeter, is called angular magnification. Now the next term is resolving power. There are different optical instruments which are used for an optical instrument like a lens. For a lens, resolving power is defined as 1 divided by alpha minimum, where alpha is the angle subtended by the 2 points which are lying at a far distance from the lens, and alpha minimum is actually the minimum distance, the minimum angle subtended by these 2 points at the lens, when these 2 points can be seen separately, P1 and P2. जब सेपरेटली देख सके हम, इस एंगल को कहते हैं अल्फा मिनिमम. एक्चुअली जब 2 पॉइंट्स करीब पड़े होते हैं और उन्हें दूर से देखा जाए तो वो बिल्कुल एक ही पॉइंट नजर आता है. ऐसे लगता है कि ये पॉइंट्स 2 नहीं है बल्कि सिंगल है. अगर उन पॉइंट्स को हम सेपरेट करते जाएं और एक खास उन दोनों पॉइंट्स के दरमियान एक खास फासले पर वो दोनों पॉइंट्स हमें सेपरेट नजर आना शुरू हो जाए, तो ये दोनों पॉइंट्स जो यहाँ एंगल बनाएंगे, जब वो सेपरेट नजर आना शुरू होते हैं, इस एंगल को, इस छोटे से छोटे एंगल को हम अल्फा मिनिमम कहते हैं. For a lens, resolving power is equal to 1 over alpha minimum. Resolving power को फिर हम यूं डिफाइन करेंगे. It is the ability of an optical instrument by which it can give the fine details of the object की fine details दे सके. उस ability को हम resolving power कहते हैं, and it is defined as 1 by alpha minimum, where alpha minimum is equal to 1.22 lambda over d. Lambda is the wavelength of light which is used to see the object, and d is diameter of the lens. Lambda is the wavelength of light used to see the object, and d is diameter of the lens. अल्फा मिनिमम की ये वैल्यू इस इक्वेशन में पुट कर दें, यहाँ पर पुट कर दीजिए तो हमारे पास ये आ जाएगा r इज इक्वल 1/1.22 लैम्डा ओवर डी, डी ऊपर चला जाएगा तो रिजॉल्विंग पावर विल बी इक्वल टू d डिवाइडेड बाय 1.22 lambda. This is the resolving power of a lens. Now for a grating, diffraction grating, resolving power is given as r is equal to lambda divided by lambda 1 minus lambda 2. Lambda 1 and lambda 2 are the wavelengths of light which are used for grating, which are used especially in spectrometer for diffraction grating. Actually, in case of spectrometer, we use sodium light, and there are two wavelengths which are very close to each other, which are emitted from sodium lamp. One wavelength is denoted by lambda 1 and the other is denoted by lambda 2. These are very close wavelengths, nearly equal. So it can be written as r is equal to lambda divided by delta lambda, where delta lambda is lambda minus lambda 2. The difference between the wavelengths. Here lambda is lambda 1 or lambda 2. As I have said earlier that lambda 1 and lambda 2 are very close to each other. I mean to say very close to each other, nearly equal. Also, for a diffraction grating, resolving power is given by n into n, where n is number of lines, opaque lines drawn per unit length of the grating. Unit length पर जितनी lines ड्रा की होती हैं, opaque lines ड्रा की होती हैं, उसे n से ज़ाहिर करते हैं, और m is the order of the image. You know, diffraction grating से जो images बनती हैं, वो मुख्तलिफ levels पे बनती हैं, और m ऑर्डर ऑफ इमेज, अगर पहली इमेज है तो m1 है, अगर दूसरी इमेज है तो m2 है, अगर तीसरी इमेज है तो m3 है, m and so on. M is the order of the image. So you can define resolving power mathematically by two equations. One is R is d divided by 1.22 lambda. This formula was given by Rayleigh, a scientist who worked in optics, and the resolving power of a grating, diffraction grating, that is given by this. In actual, we write the resolving power in this form for spectrometer. In spectrometer, we use two lights, two sodium lights having wavelengths lambda 1 and lambda 2. Lambda 1 and lambda 2 are nearly equal, very close to each other. And this is yellow light. कौन सी लाइट होती है? Yellow light होती है. Also, resolving power of a diffraction grating is given by R is equal to n into n. What is n? N is the number of lines drawn on unit length of the grating. Diffraction grating की unit length पर जो lines ड्रा की होती हैं, opaque lines ड्रा की होती हैं, गैर शफाफ लाइनें जो ड्रा की होती हैं, उसको हमने कैपिटल N से ज़ाहिर किया. This is number of lines drawn per unit length, and n is order of the image. Diffraction grating से जो images बनती हैं वो मुख्तलिफ जगहों पे बनती है. पहली इमेज का ऑर्डर 1 होता है, दूसरी का 2, तीसरी का 3, चौथी का 4, 4। तो L इज ऑर्डर ऑफ द इमेज। कल हम इंशाल्लाह इससे अगला टॉपिक करेंगे। थैंक यू।